Is there some sound? Hello? Hello, hello? Is there some sound? Hello? There is some sound, but since I am standing, I am a little bit cut off from what I see. So either I make that bigger or... Can I move the camera a little bit? That made it worse. A little bit down. I think that looks good. So my head is not cut off. Perfect, perfect. So the stream is a little bit later today because as I mentioned yesterday, I helped my parents moving to the new house and I helped a little bit longer than I initially wanted to. But that's family, of course. So of course I help. There, at least for me, there's nothing more important in life than family and really, really good friends. They are more important than anything and have the highest priority over all. Today, so before we start with all of this stuff here, I always think a little bit about the project when I go to bed and also during the day. Are there maybe some things that could be done better? Can we improve certain things? And there's always tiny little things that we can do. So first of all, what we want to do is I wanted to check something. So a couple of things. So assets, which currently does not implement the disposable interface. It's not implements. It's just a double colon. So our assets class should be disposable because it overrides the dispose function and internally needs to dispose something. And with that, we can also use the KTX extension here. So if there would be an error, we can simply ignore it. So that was one tiny little improvement that came to my mind. The other thing what we don't do and what we are completely missing is our loading screen. We are loading here this object tile map to parse all the different collision stuff from characters and so on. And we are then calling the dispose method of the screen where we don't dispose anything. But actually we want to dispose something because this tile map here is no longer necessary. But instead of moving it to the... Yeah, I actually I will use the dispose function because I thought of putting the code inside the hide function instead of show, because when we show it, we load it, and when we hide it, we should unload it. That would maybe make more sense. But our loading screen is anyway, it's just a one-time screen. We will never call it again. So I think calling dispose here is good enough. And our assets class currently has no unload function. So we need something like maybe minus would be the Kotlin pendant for that. Or we can also say unload and then pass the map asset, the objects map, because we don't want to keep this resource in our game. We loaded everything, we passed everything, so we can then simply dispose it. We could actually do that already up here. Might even make the code easier to understand and read. So let's go back here. Dispose should maybe really just be used for screen internal stuff that is really needed. Here it's really just, here's the loading and here we do then the unloading stuff. And this function is currently not available, so we will make one in our assets class. And how is it really called? I'm actually not 100% sure, but there should be unload. And we are unloading our objects path, and it's not called objects, it's the asset actually. Is that everything that we need? Removes the asset and all its dependencies if they are not used by other assets. Okay. If there are some tasks, it does something. Check if it is in the queue, then it does something. Unload from queue. Reduce the ref counter. I'm just wondering, do I need to call the finish loading stuff on that, or don't I need that? I think we might not need that. I'm not 100% sure, but we will just call here unload. What is that? Blocks until all assets are loaded. Yeah, so we will just call here unload. I think that should be hopefully good enough. And yeah, with that we can remove it. Another thing would be this operator function minus assign unary minus. Maybe just minus, not sure. To keep it more consistent with the rest of this class here, with this assets class. So we could do something like this, and with that, coming back to the loading screen, we should be able to just write it like that. Assets minus map assets object. So we remove that one from our asset manager. That's more the Kotlin style to do it. Good, so that was the second thing. Then I had two more things. I need to remember everything. One of them was the game object enumeration currently. And what I don't like here about that approach is that we are using this enumeration name as part of a key for our texture atlas. Where is it? Maybe here? Not sure. Somewhere we do .name, or is it just name and then I think lowercase? Yeah, that location here. First of all, that one, I don't like it a lot that we need to do that all the time. And also the name of the enumeration, so object.name, that one is used as a key for an atlas, which is not very intuitive when you look at that class that it is doing things like that. So what I prefer, what I want to do here, and then is, in my opinion, a better approach, is that we have here an atlas key, which is a string, and it's basically the name and lowercase. So this is what we want to have for now. We could also maybe pass it as an argument. So if for whatever reason the name is not equal to the graphic that we are using in the atlas key, that we could maybe adapt it in here. But for now, we try to stick to that approach that has less configuration needs than in the end in our game engine that we are currently writing. So we will keep it like that. And in the end, what we can then use here, we can use here then the, oops, that was wrong. We can remove here the lowercase, and instead of using the name, we are using the atlas key. That's it, I would say. Yeah. Good, so that was one more thing, and then let me think. I had one more thing in mind. It was the enumeration, it was the unloading, and the renaming of a method. So this one here is spawn ground entity, but we removed the entity creation here actually. So we could rename that to spawn ground bodies. That makes more, that is a more suitable name for that because there is no entity creation left here. Good, so those were some minor things. Hello, Nicholas. So those are some minor things and some minor improvements which I will commit now in a moment, and then we will continue with the jump mechanism for today. What's the advantage of doing this versus a C++ game? So first of all, what I prefer here in C and C++ language, you need to take care of the memory allocation. So whenever you create an object in C++, it's the new keyword. In C, I don't remember. Let's remember, or let's keep it with C++, that you always have, if you create a new object, you have new something. And at one point in time, you need to call then, I think it was delete in C++, if I remember correctly, to free up the memory. So you need to be more careful when it comes to memory management. The advantage is, of course, you are more on the low-level stuff and everything is faster. Maybe not a lot, but it is faster. And with Kotlin or with the JVM where we are currently developing, you don't need to take care of that yourself because there is this magical garbage collector in the background. And if objects simply are not referenced and used anymore in our game or in our application, then the garbage collector simply frees up all the memory stuff. So this is one thing that is for me an advantage. The second thing, that's just a personal thing. The last time when I programmed C++, that was like 20 years ago, so I cannot remember all the syntax and features, that language features which are available there with, I think there's auto pointers and all of that stuff. And for me, it's just way easier to work with Kotlin or Java in that regards, because that is what I do, almost the last 20 years now in my daily job. So I feel way more comfortable with that language than doing it with C++. And also LibGDX is a Java game library. If we want to use C++ for 2D stuff, we would need a different library or even different engine than in the end. So that's just my personal opinion. If you, of course, are a C++ programmer and that is what you want to use or do or learn, then of course stick with C++. No problem. Okay, so a quick commit here. So what did we do here? So here, assets, we made it disposable and added an unload function. Then here we have the atlas key now in the game object to make it more clear that that is used at some point. In our loading screen, we are unloading now this map because we don't need it anymore. Here we could replace it with the dispose safely because it's now disposable. And we renamed this method and also are using this atlas key in here. Finally, we need to test it, of course, before we commit that everything is still working like it was yesterday. But I think we should be fine. So if that broke something, I would be a little bit surprised. And looks good. Yep. So everything's still working. Good. So let's make, let's call it minor refactoring improvements. Of course, those commits, to be honest, the text like this is pretty bad. You should never do it like that. We should actually make maybe 3 or 4 separate commits if we want to work really in a good way. So one commit would be introduce here the atlas key. Another commit would be to have here the disposable stuff and the changes there. And the last thing would be in the spawn system to rename the function. But to be honest, I'm the only person most likely which is working on that repository. I will never look at the Git history again and blame someone, hey, who implemented that bug or added that bug to the game. It will always be me. So the accuracy or how accurate we want to work with the Git history does not really matter for that project. So, jumping. How do we want to go about jumping? We have our keyboard input processor, and basically what we want to have now, when you press the space key, for example, then we want our player to jump. When we release it, we don't want to do anything. We could implement something like in some platformer games, that when you hold the jump key, then the character is jumping higher. And when you release it, then he's falling down way quicker. So we could implement something like that, which is maybe giving a better control about the jump mechanism or the jump path that you are making as a player. But for today, it's just a very simple implementation. So what we want to have here is something that we iterate over all the player entities again, because those are the ones that we are controlling. And then maybe we have a jump component that we will create in a moment. And on the jump component, we want to say something like, I don't know, jump equals true, or in whatever way we are implementing that. So we need to think that now through. But first of all, we need a component. So if an entity can jump, then it will have a jump component. And how do we want to implement that now? So for the jump, I would say it is a little bit similar to the move component that we implemented yesterday. So most likely we will have some interpolation, because what we could do, let's see, we could have a different interpolation for how we want to jump. So for example, if we want to have a very circular path of our jump, we could use the circle out to jump up there. And then when we fall down, then it could also be again a circle. So we could use that for jumping upwards and also for falling down. But most likely we want to have a faster falling than going up. At least that is, in my opinion, a better behavior in platformer. So when you jump, the jump is a little bit slower, that you can also aim a little bit and target where you want to go. But when you fall down, it should not be very slowly. It should be way faster, so that you're fast on the ground. That makes, at least for me, that is what I expect in most platformer games. So maybe for falling down, we would have then, I don't know, a different interpolation. Let me quickly go through them. I'm not even sure if we will use an interpolation there, maybe just the Earth gravity, or we apply the gravity 2 or 3 times, which we have anyway available, or we use that one for falling. But anyway, something similar like yesterday. So what we need for sure is a timer, and then also maybe the time to reach maximum height, something like that. What we also would need is the maximum height. So basically, I think it's really the move component all over again. Let me think. We don't need a direction for sure. That does not make sense. With a jump, there's just one way that you can go. But we have a current height or speed that we go upwards. We have the maximum speed, the time, and the time to max. Okay, so that one we maybe want to do differently. I'm thinking now, for a jump, it might make more sense that we say you can jump up to 2 tiles. So the maximum would be the amount of tiles that you can jump. For example, 2, and when you pick up certain boots, then you can maybe jump 4 tiles high. I think that is easier to use than a speed, actually. Because with the speed, if we jump, I don't know, with a speed of 8, what does that mean? So depending on how long we jump, we get a different height. So with the height, I would really go with the amount of tiles that I want to reach. And for that, most likely we need some formula where we use AI to help us, because most likely I cannot come up with it. Yes, and then of course still a current speed that we need. the time and the time to max. So maybe we can still use there the interpolation, but not 100% sure. Hello, Schlaubi. When you look at my app, please, I want to go outside before it gets dark outside. Then go outside. We can look at it tomorrow, because tomorrow I don't have any plans on Sunday, so I will come to Discord. Then we can chat a little bit and you can show me the application. I think that would be good. If you have time tomorrow, of course. But I'm free the entire day. So, AI, let me, please help me. I need a formula for a jump functionality in my 2D-Platformer game. By the way, just for your information, I know a little bit how you should prompt these AIs. So one thing is you should not give them too many questions or too many possibilities to answer. Just ask for one specific thing that you want to achieve. And yeah, so that is what I'm trying to do. And also give them a lot of input so that they know what they should do. And that is what I try to do now. So we need a formula for a jump functionality in my 2D-Platformer game. I want to define a maximum height that the character can reach. For example, character can jump 2 tiles high. So I want to specify the maximum height of the jump with a value of 2. Then I have a system that gets called every frame, and I want to update the velocity y value to reach the given maximum height within a given time. What I want to do is that I specify the maximum height and the time to reach it, and the system should figure out the velocity that it needs to set to reach this height. Can you give me the Java code for the mathematical formula, please? Let's see if it can do that. And if it understood me, here's the Java code for the jump functionality with the formula to reach a specified maximum height within a given time. Okay. Update jump. If y velocity greater 0, so we are jumping. Apply gravity after reaching the peak. Physics, gravity, delta time. Okay, so this would be the falling part. Not sure why it gives me that as well, but I didn't ask for that. The other thing would be calculate initial jump velocity to reach maximum height in jump time. So we have initial jump velocity is 2 times the maximum height divided by the jump time. What the hell? Why? 2 times the maximum height divided by the jump time. I don't understand that. Maybe it's correct. We will try that out, but why? I really don't get that. And then gradually decrease velocity over jump time. That also does not make sense to me. It must be a plus because we want to go upwards. And it has here the initial jump velocity times delta time. And if you're not jumping, then it sets the velocity to 0 and update y position based on velocity. So blah, 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 blah. Multiplied again by the delta time. So I'm not sure if that is 100% correct, but this piece here is the important one that we need. I'm wondering if that works, but we will see that in a moment. But I think we don't need a couple of those things. So first of all, we need a maximum, that's for sure. And then we just have a initial jump to reach that, most likely in linear time. I need to feel that in the game then itself, how that will feel like. But basically we have then the how do we call? Yeah, let's still call it current. A timer we don't need, and time to maximum we will need. The timer we don't need because we won't do an interpolation. Or let me think that through myself. I have another idea, but not sure if that is working. So the interpolation classes here in LibGDX, they always go from 0 to 1. So basically within 1 second, if we always add the delta time here, after 1 second, it reaches whatever value is specified here, which is also just going from 0 to 1. What we want here is actually the height of our jump. So for us, it would be 0 to whatever the amount of height we want to jump. And then the time is, instead of doing it within a second, it's what we did with the move system. So we can then just multiply it with delta time, and we did something else. I would need to check that. But then in the end, we reach our desired height within the given time and with whatever interpolation we want to use here. I don't even need the AI. I am the AI. Damn, am I smart. So not sure if that works, to be honest, but I think it should. At least in theory it should. So let's keep all of that and create a new system. Our jump system, and it's mostly the move system again. So we have an iterating system. Our family is all entities which have a jump component. That is what we need. Then we have the method to update the entity, and that's it. And then let's have a sneak peek at the move system. So what did we do here? So timer, it was the current timer plus the delta time, and then 1 divided by the amount of time that we want to have. Yeah, okay, so that part we need, and that one we need as well. Yeah. So with this little piece of information here, we should be able to get our jump behavior that we want. So let's use the destructuring. We have current, max, timer, time to max. What we don't know yet, so we don't know if an entity wants to jump. So there is some indicator missing. And this is one piece of functionality that I want to add. I'm not sure, is it jump buffering in that case? I think it's the jump buffering actually, which means when we are pressing the jump button, there should be a little bit of a tolerance, which allows the player to still jump. What I mean by that, imagine we have a flat surface. So for example, that would be our ground here. And we have a player, which is very simple. It's maybe just this box here, and he's falling down. So when I, as a player, press the jump button, I don't... let me start in a different way. So we can only jump if we are touching the ground. So initially, the player has to be on the ground surface. there will be some contact listening and some sensors which are telling us that the player is in contact with the ground. And when he does that, he can jump. That's the start of the jump. At some point, the player will fall down. And now when he's falling down and we as a player, we press the jump button again because we want to do a second one, we don't want to have that frame perfect. So when I press the jump button, it should always work when I'm within a certain range of the ground. So meaning that when I press it, for example, here, and quarter of a second later, I touch the ground and the sensors are then triggering so that they know, okay, I am on the ground, I can jump again, then the player should automatically jump again. Instead of really, so when the player gets in contact here, that only at that point in time, the player can give the input again for a jump. That is not very nice. So we want to have some buffer time, let's say, some tolerance where the jumping is still possible. And that is one thing that we will implement. The second thing, the coyote time, is, if I remember it, a similar thing. So when you run off an edge, let's say you are here, and let me zoom in some more. And at that point in time, the player is not in contact anymore with the ground. And if we have it very accurately, you would not be allowed to jump here anymore because there is no contact, so the player would fall down. But since we were just running and we wanted to jump as late as possible, so it should be possible that you can jump from here, up until maybe something like here. That there should also be a little bit of a tolerance where you can still jump, although you are not in contact with the ground anymore. So those are the two mechanisms that we want to implement. And to do that, I'm thinking of when the player presses jump, maybe we set a jump timer. So for example, to a quarter second, this timer gets subtracted then in the jump system. And if it's greater 0 and we are allowed to jump, then we do the jump. And if it's 0 again, then we just know there is no jump command fired by the player. So what we need is here we have current, we have maximum, we have the timer, we have the time to max, and the first variable maybe would be the it's not really that one. Let's make it the last one. It's the, let's call it jump timer, but that would be very similar to that one here. Jump buffer. Let's call it buffer, which initially is 0. So you don't need to pass that. And the buffer is the one, maybe we add some comments here later on, but the buffer is the one that we use to know if the player wants to jump or not. So in here, we can destructure one more attribute. And now here, if the buffer is greater 0, then entity wants to jump. Of course, we also would need to have here a check that he can really jump, but for now, we allow the player to do double and triple jump. So whenever we press it, we want to jump it. The real improvement and the correct behavior comes then tomorrow, if I remember correctly, but not sure. But that comes later on, so we for sure will implement that. So here we know that we want to jump. And now the buffer, we can set the buffer to 0 here because we are, oh, that needs to be a variable, because we are jumping here at that point in time. And let me think. I think I need to write it the other way around. Because the system also, so it should not do anything here if we have certain conditions. So if the buffer is 0, which means there was no jump commands pressed, and maybe the timer is also 0 because that one gets updated then below at some point. So if we have that, then no entity does not want to jump. And there is currently no jump in progress. Timer equals 0. And that one is buffer equals 0. Okay, so here below we know that the entity does not want to jump. So here we know entity wants to jump, or there is a jump in progress. So the easier thing to check here, so if the timer is greater 0, then that's the case jump in progress. And here we simply need to update the timer with those values here. And we use the interpolation class from LibGDX. And we don't have, what kind of interpolation do we use for the jump? Let's try circle out. Yeah, let's try circle out. We can change that on demand. Interpolation, circle out, and then we apply 0, and the maximum is it's actually let's rename that to maximum height. Also here, let's rename it to maximum height to make it more clear or clearer what that is. So between 0 and the maximum height. So that is what we want to reach. And we have the timer. And when we have that, we just, what do we need to do? We need to update the values in the component. And I think that's it. So we have here the jump component. And the only thing that we do here is from our jump component, we set the current value and then we return. There's nothing else that needs to be done. So the current value is not really needed. We write here the underscore. So jump in progress. And if the jump is not in progress, then start a new jump. And that's maybe exactly the same. Let me think, do I even need that specific case? So when we have the buffer 0 and timer 0, we don't do anything. If either the timer or the buffer is greater 0, here we would have the scenario the buffer is greater 0 and the timer did not start yet. This is the only time when we come here. And what we want to do here to start a new jump, it's exactly that again. Because we want to update then the timer and we want to set the height of the entity. Correct? Yes. Yes, that is what we want. So it does not matter at all. Since it's the same code, we can simply skip this if and remove all of that. That's it, right? Oh, what we did not do, we need to reduce the buffer time, of course. So what we need to do, buffer minus equals delta time. And maybe we want to do that up here. No, I think below is the correct place. So we would subtract the buffer, which should also maybe be limited, that it does not go below 0, because that does not make sense. Buffer minus delta time, and at least the minimum value would be 0. And we can simply set it like this. Okay. Let's move that below the comments, up, like here. And is that already it? So we reduce the buffer time. Here there would be some, okay, that maybe comes later on to do. Add check if entity touches the ground and really can jump before starting the jump. So that's currently missing, but for now, that's really it. So if we ever reach that point here, we can jump and we want to jump. And I think this is not correct with what I wanted to achieve, but we come to that in a moment. So first of all, in our spawn system where we have the player, when we are a player, we want to add the jump component so that our player can jump. And the maximum height is maybe 3 tiles, let's say. And what else do we need? We need the time to reach that. And that should be to get to the maximum jump. It's maybe 1.5 seconds to reach that. So now the player can jump. And one more thing here in our controller, we would set now from when we have the jump component. Why is it that long with the qualifier? I'm not sure. We will set the buffer to like 1/4 second. So that's a constant that we will move to the jump component in a moment. But yeah, basically that's what we want. Okay, can I now import that? Why do I need the qualifier? Why is it so stupid? Okay, now we got it. So that should be it, but we are, oh, there's one piece missing. So in our physics system, and that's now where the problem, in my opinion, comes in place. But let's see. So if an entity has a jump component, then we will get it. And from our body, we set the linear velocity to... That's a good question. Is that value already ready on the body and I can get it like that? Or do I get here the old value? We will see that in a moment. And here we will set this current information. So update linear velocity if entity has a jump component. Linear velocity X and linear velocity Y. And one more thing, I think we did not add the jump system yet, which we can add, for example, after the move system, but before the physics system. That would be cool. And now let's see. So I think at least some jump should be happening. So as you can see, we are rising. Are we ever falling down? We are not, because we never reset the the current value of our jump component. So that's why we are rising indefinitely. But also what we are implemented is not correct, because I mixed two things. So the first thing here, what I meant with reaching a height in a specific time, everything of that was correct. Also, we are calculating the current height that we actually would need. But what we need to set in the physics system is actually the speed of the body. So how fast should it go upwards to reach that? So the way I implemented this jump system, that does not make sense. Because we are not setting the height, we cannot set that. we need to set the speed actually. So that brings me back to whatever formula that one was. And we need to try that out. And also we need to reset current value to 0 when jump has stopped. Yeah, that's a little bit tricky to implement, but we will be able to do that. But I need a short break again. And during that break, I give you some background music. If you have some cool idea how to implement this jump stuff, give me some hints. Otherwise, I, of course, think it through myself. And we try to finish something today. It will be for sure not the best jump mechanism that you have ever seen, but it will be something that should work. Okay, back to this chill out mix. I'm back in 5 to 10 minutes. And we are back. And we want to sit. So let me bring down the desk. Okay. I think that's good. And hello, Elizabeth. What did he say? For Android development, I'd imagine Java Kotlin is much better since the whole system is tailored to it. Plus, you get garbage collection, etc. You mean for the question number 1 with the C++ stuff? Yes, that's also one benefit. I'm not even sure. Can you even run C++ stuff on mobile phones? That's of course, but that's a good advantage actually that Java Kotlin, they have many target platforms in mind, so you can deploy them everywhere and run them everywhere, which is also a benefit. Not sure if that's possible with C++. Coming back to our jump. So AI told us that this should be the formula so that we know this is the speed that we need to set to get to that specific height within that given time. We will make an example if that makes sense. So let's say we want to jump. Our maximum jump height is 4. We want to reach that to have it very simple within 1 second. So what that formula would do, it would double the jump height, which would be 8, and divide it by that, which is 1. So we would have an initial jump velocity of 8, which means if it's constant, we reach actually a height of 8 instead of 4. Why the hell is it doubling the jump height? I think without that, that would make more sense. So if we don't double it, it's 4. Imagine we want to reach that in 2 seconds. So our speed would be 2. Which also makes sense. Then we need 2 seconds to reach 4. If our jump time would be half a second, then this one would be 8. That makes way more sense. I don't know why it multiplies here by 2. Why Google Gemini thinks that we should do that, but I think it's wrong. So this is more like an instant calculation, so there is no interpolation happening at all. And we would actually need to consider also the gravity which is applied. So let me give it one more try. I think the AI did everything that it can incorrectly. So let's go back to our previous chat. Did it explain somewhere why it multiplied it by 2? Did it is calculated using this formula? This formula uses the fact that at the peak of the jump, the vertical velocity is 0. By solving the kinematic equations for constant acceleration gravity, we can derive this formula to achieve the desired maximum height within the specified time. But shouldn't there be the gravity be factored in somehow? The initial jump velocity is then gradually decreased over jump time. to simulate the character falling back down. If the character is not jumping, the velocity is set to 0. Finally, the character's position is updated, blah, blah, blah. Why does the initial jump velocity formula not consider the value of the gravity? You're absolutely right. The initial jump velocity formula we used ignores the value of gravity. Here's a more accurate formula that takes gravity into account. So it's the square root of 2 times the jump height times the gravity times the jump time. Okay, this formula uses the square root of a term that includes gravity. This approach comes from the kinematic equations for constant acceleration, specifically for the scenario where the final velocity is 0. Here's why gravity wasn't explicitly included in the first formula. The simplified formula assumes we only care about achieving the desired maximum height. By the time the character reaches the peak and the velocity becomes 0, gravity has already played its role in slowing down the character. The simplified formula essentially backwards calculates the initial velocity needed to reach that peak, considering the total time for the ascent. However, the simplified formula can be less precise, specifically for very short jump times. Including gravity in the formula provides a more accurate calculation and is simply amazing. Okay, so let's try that. So this should be the velocity that we apply. But just once. So I want to try quickly a different approach. Instead of updating it here every frame, let's comment that out for a moment. We will come back to our jump system and we also comment out everything here for now. So, not everything. So if the buffer time is 0, the timer we can also remove. So if we don't want to jump, then do nothing. Otherwise, we set the buffer again to 0 so that we don't jump again. And what we also do now, so very quickly, just to see if that approach would, in theory, really work somehow. So we don't need the previous position. So here we set then the linear velocity directly. And we set it to this formula that we got, which I did not copy. So what we want to have is the square root. Is there SQRT? It's nothing there. But is there a Kotlin default function? So we will use that one for now. Then it's 2 times the maximum height times the physics world gravity value. Do we get that out from the physics world? I'm not sure. Is that possible? So physics world dot gravity dot y. Okay, that's possible. And then times the jump time. So we called that time to max, I think. So this is what the AI told us the formula should be. Again, let's check. So the square root of 2 times the maximum height times the physics gravity times the jump time. That should be the initial speed that we set. Let's try that out. It does nothing. Okay, but I cannot even move the character anymore, which is also interesting. What the hell is breaking it? So if I don't jump, I can move. So somehow when I jump, maybe because it's entering here multiple times. Not sure. Let's see, I jump. I expect that I only end up here once, but I end up here 2 times. And the player disappeared. He went to heaven. Why did I enter here 2 times and why is that even a problem? So I press the jump button. I come in here. I set the buffer back to 0 on the component and I set the linear velocity of the body. Oh, ha. Here is still something happening. Let's remove that code here as well. Okay. Let's try again. Maybe that was the problem. So he's leaving out of space immediately. What the hell? Why is that the case? Why is that really the case? Wait, I don't get it. I think that's a huge number, right? Which comes out of that equation. Okay, so the square root here, it's not a number. Really? Why? That thing here is minus 88 because that's quite big. So let's remove it step by step. So maximum height is 6 because we want to jump 3 tiles high. Then we want to reach it in 1.5 seconds, which is then 9. Yeah, and then somehow gravity comes into place, which seems to have a huge value. It's not that big, it's minus 9, but it's multiplied by that again. So we actually have a negative jump speed, which is completely stupid. So that needs to be minus, of course. But I think we jump up top. Oh, no, that looks better. But it's actually way too high. So we just want to jump. What did we say? 6? Did we say 6 tiles or 3 tiles? Wait. Spawn system. We said we want to jump 3 tiles. But he's jumping. What is that? 1, 2, 3, 4, 5, 6. It's way too high. Way too high. To get a better understanding how high we are jumping, let's modify the map a little bit. So first of all, there's foreground information. We don't need it at all. And we will add here now some random tiles. Let's use those ones. So 1, 2, 3, 4, 5, 6. Maybe to make it easier to understand how high we are really jumping, let's use different tiles. So that would be 1, that would be 2, then we have 3, then we have 4, 5, and the final one, 6. So something like that. And it seems like we are jumping way too high, and I always confused about this 2 times something. So let's remove this 2 times stuff here. Okay, so we jump now. That looks now better. So that feels like we are jumping 3 tiles high. maybe not 100% accurate, but it looks like it a little bit. The time, I'm not sure if you reached that. For that one, we would really need to write a test to see where we really end up with those numbers. Let's say I want to jump now 5 tiles high. Does that also work? No. 1, 2, 3, 4, 5. It should be up there, but it doesn't reach that. No. Nope. So the formula for sure is not correct. Let's give the AI one more chance. Seems like the formula is not correct because I don't reach the expected height within the given time. Did you maybe do a mistake? We give it one more chance, then we are Googling. You're right, there might be a mistake in the formula implementation. Here are some potential reasons why you might not be reaching the expected height. Missing factor of 2. The formula we provided for the initial jump velocity with gravity is missing a factor of 2. The corrected formula should be, so it even multiplies it higher. Now it went up to 4 instead of 2. Nah, I don't trust it anymore. Physics formula to reach, to calculate a start velocity to reach a specific height in a given time. That is what we want. Calculating initial, how was that called? Wait. Calculating initial velocity needed to reach specified height. Yeah, that is what we want. Okay, maybe I should phrase the problem. Looks like, what is that thread? How do you calculate the initial velocity needed to reach a specified height? To calculate the initial velocity needed to reach a specific height, you can use the formula speed equals the square root 2 times, so there's this 2, g times h, where v is the initial velocity, g is the acceleration due to gravity, and h is the specified height. Okay, so 2 times gravity times height. Back to our jump system, so it's 2 times the gravity times the height. Let's remove the time factor. Is that already it? Let's see. So we want to jump now 1, 2, 3, 4, 5. I think we said 5. But in my opinion, it's still not correct because the bottom here should be then up there. And it's not up there. It's somewhere here. It's simply not correct. What if we use a maximum height of 3 again? That's also not correct. At least it's not accurate. So it's almost what we want, but it's not perfect. Why? Is it a problem with the square root? No, I don't believe that the square root is the problem. Weird. Anyone has an idea how we can solve that? What unit should be used when calculating for specific height? The units for initial velocity will depend on the units used for acceleration due to gravity and height. In most cases, it is recommended to use meters per second for velocity, meters for height, and meters per second squared for acceleration due to gravity. Can the initial velocity needed to reach the height ever be negative? No. How does air resistance affect the calculation? No. Is the calculation of initial affected by the mass? Yes, the mass of the object does affect the calculation. Heavier objects will require a greater initial velocity to reach the same specified height compared to lighter objects as they have more inertia. What the hell does that mean? And require more force to move upwards. So what does that mean? Do I need to multiply the mass in here as well? So first of all, sorry, Google AI, I played you poorly. You had the correct formula. I also need to consider the mass of the character. Please give me the updated formula. Unfortunately, in the context of a simple 2D platformer with constant gravity, the character mass doesn't directly affect the jump height. Aha. But the other link said we should do that. If your game engine uses a physics system that simulates forces and calculates mass-dependent acceleration, then a jump functionality would likely involve applying a jump force instead of directly setting the velocity. Here is a simplified example. So jump force is mass times jump strength. In this case, jump strength would be a value representing the force applied to initiate the jump, and mass would be the character's mass. This force would then be used by the physics engine to calculate the resulting blah blah blah. Okay, how do I calculate the jump strength? Calculating the perfect jump strength value for your game depends on several factors, blah blah blah. Assuming your game uses mass-dependent acceleration, we can use a modified version of the projectile motion formula. Okay, so it's 2 times times mass divided by the jump time squared. So jump time for now is just 1, so that one can be ignored. We just need this one here. Let's try that one. So we have body, apply force. Apply force to center. I guess that is what we want. So on the x coordinate, we don't apply a force. On the y coordinate, it's that one. And we want to wake up the character if needed. So maximum jump height is max, and the mass is body mass. That's it. Let's see. He is not jumping at all. He's moving, but not jumping. Not sure why. Coming back here. What is the mass of our body? So let me just try something. So what happens if I multiply with the mass? Does that solve it? No, it's still not high enough. I think it's actually the same value that we had before. So what is the mass of our body? It is 1. Okay. So also we had a formula where it said 4 instead of 2. That's way too high. We want to jump now 3 tiles high, but we are jumping crazily high. Is all the values that are coming here, they are correct, right? So we have the maximum height of 3. We have the body mass, we have the gravity. We set that and then it slowly decelerates. Okay, the last thing that I could come up or I can imagine that might help us is the official documentation. Other than that, I have no idea how we can say that we want to reach a specific height. And it's really just throwing in random numbers and see if they just work, which I don't like a lot. So let's read some documentation here. So a platformer game character's got a jump, right? Let's take a look at some different ways of implementing a jump. Setting the velocity directly. When the player character jumps, their velocity changes. So let's try doing that to start with. Yeah. Now using the blah, 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 using a force. When you jump in real life, you are applying a force. So let's see if we can do that by using a strong force for a few time steps. This is not what we want. Also, that for whatever reason didn't work. Impulse, I also don't want that. Stopping the body from rotating. That one we have as well, I think. Does not really help me at all. So what else do we have? Move at constant speed, jumping, sensors. Box 2D. Jump to specific height within given time. Let's see if we can find another block somewhere. Never use forces to jump. Force has different effects based on how long that force acted. Second, don't use linear damping. It makes your physics floaty and not real. You could use impulse instead of force in jumping method. It does mirror. I'm using this method and it works perfectly. So grounded, if grounded, set linear velocity, blah, blah, blah. So he's setting here a fixed value. Linear damping, is that our problem? Not sure. Calculating the force to jump an exact distance. I want my character to always jump a constant height. Let's say 3 meters. Also, character has double jump. Okay, formula y g times the time squared plus something something. This one we had, but I don't know what vi is. What is vi? The speed at a given time, maybe? In another form, blah, blah, blah. To find the first jump initial velocity, you set y to 3 and v to 0 and solve for t, which is something. Use that to solve for vi, which is blah, blah, blah. What? So that's the initial, I get it. The initial jump velocity, v is 0. So we have 2 times the gravity times t. Why is t that value? Where's that coming from? Let's say 3 meters. Also character has double jump ability, so he can jump maximum 6 meters. Let's say I have pressed jump key while player is on the ground, and as soon as he reaches 1 meter in height, I press jump key again and he performs double jump and reaches 4 meters. Yeah, okay. The second jump is a little more involved. Blah, blah, blah. You said This answer could really benefit from some variable explanations. Yes, it really could. So I don't get why is t half a second here. I have my height that I want to reach. Let me write that down. So I have my heights that I want to reach, which in our case would be 3. I have the gravity, which is 9 point something, let's say 10 times t squared plus bi, which we don't know, times t plus iy, whatever is iy. In the end, in another form, it's then this one. So we have bi is equal our height, 3 minus 10 times the time squared plus ey divided by t. And finally, he gets this one here. So that's the value that we want to calculate. V is 0 because we are starting the jump. Maybe we need to update it then every frame. Is that our problem? So that's the initial jump stuff. We have that here. We can remove the body or the mass. Maybe we need to include it. Let's see. But we have that formula here already below. That one here is our formula from here. But we don't reach the heights that we want to reach. That's the problem that I see. Or am I wrong with that? Wait, one more. I have now some idea. Here, like 2 pixels. I forgot about that. I did not consider that. It's actually 2 pixels below the ground. So somewhere here. How can we easily see if that one is working? I need the current y coordinate and then the one that I have up here. So those 2 things I would need to debug. Since the jump system gets called every frame, let's try something. So we have here, that is when the jump starts. So here we simply make a print line for now. And we say start. And that is from our physics body position y. Let's move that up here as well. And here, if body position y, if the velocity is smaller equals 0, so when we are turning backwards, then we print here end. And I don't want to spam that all the time. I just want to print it once. So we have a quick flag here, which is false. Here we set the flag to true. And if flag and flag equals false, I think that should help us. Let's see. So we are here, we are jumping. We had 3.8 and at the end we had 6.7. And of course there can be a little bit of an intolerance, or a little bit of a tolerance. But it seems to be always exactly the same. Okay, so it's almost exactly the same value every time, and it's almost the height of 3. What I could imagine, because the physics system is not running every frame. Also this detection here when we are really moving backwards, so that might not be 100% accurate, but actually it looks like this is almost 3 every time, so it's not that far off. So the last thing that we want to try now, let's say if we want to jump a height of 5, then yeah, that's also almost 5. I think we go with that. Yeah. I would say we go with that. It's a little bit weird. Is that a good... Huh. I don't know if that is a good jump behavior if we jump slowly up there. We could... Let me think. We could implement it completely differently. So another idea that I now have is that we set a very high speed for the jump. Not very high, but a little bit. And keep that value constantly. So we turn off gravity, first of all. Then we set this high speed, and the jump component, it knows the starting point of the jump, so the one that we have here. And every frame it checks if we reached the height that we wanted to reach. And if we did it, then it sets a negative amount for the velocity so that we fall down. But that would be also not a very good behavior because then we are very fast when we go up and we would initially turn back. So that's also a little bit weird. So in the game itself, most likely we will have a value of 3. So that we can jump up to blocks like that one here. Yeah, I'm thinking now, I want that the jump is a little bit faster, but without modifying the height. So what I would need a heavier gravity. Yeah, let's try that. So I play a little bit around here with the values now, but I don't want to waste too much time on that. But just a little bit. So we have here a gravity of 0. And on the y coordinate, let's say it's maybe 3 times the gravity that we had before. Let's see how that one works. Yeah, so now the jump is faster, of course. It's a little bit faster. I think it's better. It's maybe... Yeah, I like it. So I think that's better. So we have a heavier gravity. We are a little bit off here still with the jump height. I'm not 100% sure why. I'm really not 100% sure why. Maybe we would need to set or update the y velocity over time as well somehow. But yeah, not sure. Anyway, to move forward and get this somehow going a little bit, we will now use that thing here, but that is, as I mentioned at the beginning, it's just setting an initial velocity directly. So I would prefer that we call that one here in the physics system. And I think maybe instead of that the player has the jump component all the time, we just add the jump component when we press the space key and set this value. And that should be already sufficient. Yes, I think so. So we have a jump component. The only thing that we need is the jump speed, or let's just call it speed, which is a float that needs to be passed. And it's actually a constant value. That's all we need. And in the physics system, it's also rather simple. So that one we don't need. And the y velocity is equal if entity, no, we can do it differently. So entity get or null the jump component. Okay, and then here, let me think. We set here the value every frame, but we just want to set this here once. And then remove it. So something like this. So if the jump component is not equal to null, then we set here the jump component speeds and also entity minus equals jump. But I think I need to, is it called entity configure? It minus equals jump. So we remove the jump component when we applied the speed, and otherwise it's the body linear velocity y. So it's something like this. Okay, then the jump system is currently not needed at all. But with that one, we complicated, really complicated. We are losing the functionality with the jump buffering. I don't want that. Haha. So the speed is okay. We need a buffer. Yeah, I think we need to set that a little bit differently, yeah. So my initial idea is not working at all. But then I would say it differently. So here the jump is not the speed. We want to set the height of the jump, which gets passed. And also that's then the variable, to be honest, that can change over time. And that is more like the maximum height that we can jump. And the buffer, which is initially always 0. Okay, so step-by-step spawn system, we say here now that the player can jump a maximum of 3 tiles high. That's this one here. Then in the controller, now we called it input processor, exactly. So there we set this buffer time, which we now make a constant here. Jump buffer time is 1/4 second. Yep. So that's it. And then in the jump system, so coming back here now, we want the physics world in here. Also, that's then only considering entities which have a jump component and also a physics component. So maybe in the future we have a different jump system without physics, but for now it is with physics. So we have a jump physics system, something like this. Okay, let's bring that up here. So finally, what we need the jump component, we need the physics body. We have here the maximum height and the buffer. We don't have more. Then this was just some debugging. Then if the buffer is 0, entity does not want to jump. Is that correct? Yes. So the buffer expired. Then there is nothing to do. Otherwise, if there is a buffer, we want to reduce it. Okay, here it's simpler because currently we always jump. So to do, check if entity can jump because entity is grounded. So this is something that we need to add later on. For now, we don't have that. So whenever there is a buffer greater 0, we then set it to 0, do not jump again. And then we simply, oh, by the way, why did we have here the square root? Now that I see that. Isn't it just 2 times the gravity times the square root of something? That was the double jump. Here the initial velocity was just 2 times gravity times the time. You set y to 3 and v to 0. And solve for t. Use that to solve for vi, which is 10 something. That one I'm confused. Let me check one more time. We had a great article before. Can I find that again? Was it with the square root or without the square root? I cannot imagine. I cannot remember. Fuck. I lost it. I get distracted too much. So here, let me come back to that one here. So for now, we live with this formula, which is not 100% correct. So when we are here, we want to jump. So we set the buffer to 0 and then we set this linear velocity, which is currently the square root 2 times the maximum height plus times the mass times the gravity of our physics world. And that's it. So this is all some debugging stuff that we don't need. Okay. Do we need anything else? I think that's it. And in our physics system, we don't have that at all. So it's back to what we had initially, which is just that piece of code here. Right? So now everything should be cleaned up and the jump is hopefully still working. Yes. Yes, it's working. What happens if we remove the square root? I think then we are jumping maybe way too high, right? Yes. It's at a crazy high jump. So square root for sure is needed. So for whatever reason, we are not jumping exactly the height that I want to jump, but it's better than nothing. So let me bring that to a new line. That one is a new line. And that's it. So we now have, after 2 hours or so, we have a jump mechanism, which is not great, but it is something. Okay. Okay. We might need to optimize that, but let's see. So what we have the jump buffering. So that one is working. And what else? The coyote time we currently don't have. I am thinking more about going now to the tests, which might also make it then easier to identify the problem or to fix the problem with the jump height. And here for sure, at some day later on, we need to optimize this jumping behavior a little bit. Currently, it's also hard to verify it a little bit because there's nothing in the game. So there's nothing where I need to jump to. So that's a little bit weird to test. It feels okay-ish, I would say, but not super great. It's okay-ish, but not super great. Yeah, so let's create a test source set. Isn't it here? It's not here. It's one level upwards. So test Kotlin. And there we have a class which we call maybe jump test. Or even better, we go to our jump physics system. And in here, we create now a test case. Okay. And what do we need for the test? We need a world, which does not have a lot. It just needs a physics world as well. And we want to have the exact, we don't need to use the exact same world, but it helps, I think, here if we have the same as in the game. So we just copy paste it here. Then we need to inject this physics world and also systems. We don't need a lot of them. We need the jump system because we want to test it, and we need the physics system to step the physics simulation. And that's everything that we need for the test scenario here. So we write a test. We don't have any test dependencies here. So I think, how is it called? Is it called Kotlin test? That we need not to the... Where's the test class? Why is it in the LWG3 and not in the core package? So that is, first of all, not correct. So let's move that one up here. Yeah. Just do it. No, that was the wrong one. I want to move that one here. Up here. Okay. Okay, it did not do the things that I wanted to do. I hate it. Why is it always just one folder? Put everything up there. For God's sake. Okay. I think we did it. So this is what we wanted to have initially. And in here we have a build Gradle file, and there should be some test API. And what we want to have is JetBrains, Kotlin, and it's Kotlin test. Not sure, something like that. So Kotlin Gradle test dependency. So we have, first of all, this dependency. And we need to have the test task available as well. So this should be everything that we need. Let's see if it still builds. Yep, with that I should have a test annotation. Yes, I have it. And we have here a test jump system method. So we need an entity which is from our world, a new entity, and this entity has a jump component. And it should jump a height of 2, for example. And it also needs a physics component. There we need the body, and that's it. How did we get the body for the... okay, let's create a very simple body configure, or is it create body? Or is it physics world body? It's like this. Okay, so we have... Let's make it one step up here. So there we get out a body from that function call here and pass it to the physics system. And what we need in here is a box, very simple, with a height of 1, a width of 1, and a position of 0, 0. So the box is around that, and also gravity. The simple test case would be that we don't have gravity at all. So let's try it first of all without gravity. So we have here vector 2, 0, that we don't have gravity here at all. So here we have our entity that can jump, which has a physics body, which is just a box at position 0, 0. And also here a buffer that the entity is automatically jumping. And what we want to have now is something like world.update. And the question is, how many world steps do we need to reach the desired height? Let's see. So from our world, we get a specific system, which is the physics system. And oh wait, what is even easier here? So the physics system for testing purposes, which makes it a little bit easier. We also want to get here an interval, which is of type how is it called? Of type interval actually. And the default value is this one here. And we passed it then to the system constructor, because that way we can test it in a more convenient way. Because now we can say that our physics system has an interval which runs at a fixed rate of once per second. That makes it way easier to test. Should also be more accurate. So we don't need that here at all. And we update our world now one time, which updates the entity position. Let's see where we would be here. So here we would have then our, let's call that here with world, that we are in the context of the world. So we update the world, and also we want to get from our entity, from the physics component, the body, the position, and the y coordinate. So that would be the test case. And here we could now verify if we are jumping correctly, which we already know we don't, but still we could verify it like that. There was a problem. We might need, yeah, I'm pretty sure we might need a running GDX instance or whatever that is called, so that we can even interact with Box2D. Okay, so what we need to do is all of that stuff that we have here, the Box2D platform. Maybe we just need this one. I'm not 100% sure, but let's try it out. So core project, build Gradle, and in our test source set, we want to have another dependency, which is the Box2D platform. Is that already sufficient to create a world? Yes, perfect. So we just need that one. And what was actually the result now? 0, 0. Why? Shouldn't we get into the physics system once and update it? Let's make a breakpoint here. Let's go to our physics system and let's make a breakpoint also here. And let's run our test once more. Okay, so we are in our jump system and we have a buffer. So we apply here the height. We want to jump 2 tiles high. We have the gravity of 0. Haha, that's interesting. So we have the root of 0, which is 0, so we don't jump at all. That's interesting. So if we have gravity, our jump system does not work. That's cool. That's really cool. A nice bug. But let's solve that. So we have gravity y. And it's something like if physics gravity is 0, then we want to multiply with 1. And otherwise it's minus physics world gravity y. So first bug already found. That's good. That's why we write tests. So now we have still 0 y. With maximum height of 2, which is 4. We have, oh, the body does not have a mass. Interesting. But anyway, the mass, I think, wasn't that important. And also that one should be... No, it should be 1. That's fine. Okay. So once more, now we have a value. So now we should jump at least some specific height. And we should now have a value greater than 0. No. Why are we not jumping? So we update here, which should bring us in the system, and we are stepping our physics world. Which okay, once more. We don't have a move component. No, but that doesn't matter. The move component does not influence the jump at all. Also, we don't get in this function here. Is the test setup maybe not correct? No, the entity, I don't get it. The entity has a jump component. It has a physics component. We call update to it. The physics system gets updated once a second. I'm confused. Why is this test failing completely? Let's analyze it. So we have the physics system. There should be a family. It requires a graphic component as well. That's not correct. We need a graphic component, of course, here for the interpolation, but it's not a mandatory component. So we remove that one. And I would say, so what kind of update do we need? We either need a move component or a graphic component. So those two, then it should do something with the entity. Otherwise, it just updates the physics world, which is in our case also good enough. But for whatever reason, it did not really update. But anyway, all, and then we have here any, or how was that called? All, and then any, and then we have either a move component or a graphic component. So that's also a tiny little fix that we found out now with our test. What I still don't get is, why is our body not moving? Because we are stepping the world. Yes, we are stepping the world once, right? Yes. So we are stepping the world once, but we are not jumping. Let's update the world 3 times. Still 0. I can't believe that. Why? Let's print one more thing. So we have here the jump. That does not help us. Let's print from the physics, the body, the linear velocity y. that should have a value. No. Why? What is wrong here? So we set here the linear velocity to 2 for that body. So this body here, body linear velocity has 0, 0. Yeah, because I don't know, does it get updated? Later on in the simulation, because that value for sure here gives us 2. So we have that. I don't get that. How does it behave in the normal game? So we are jumping. We set here value to 13. And most likely on the body linear velocity, it is 13. Immediately. But in our test system, it is not 13. Huh? What the hell? No, it's 0. Why is it 0? We set it here to a value of 2, not 0. I don't get it. What is wrong? I really don't get it. Yeah. Is there a problem that what I could think of, that this dependency here is not sufficient and the interaction with box2D does not work at the moment, at least not 100%. Let's try here again if we would have the gravity from our game screen. That is so that we have exactly the same thing. With auto clear forces to false. Okay. And now the only difference would be in the real game, we have the libGDX context and everything. Yeah, okay. So I'm pretty confident that the dependencies here are not correct and we need more. We need a real libGDX context, maybe, that everything is then really working. So let's get all of that into our core package and make all of that a test implementation. And finally, we most likely need a launcher like this. But how can I then test that? Is there, I remember there is some libGDX headless. Or maybe something how to test box2D in libGDX in a separate test class. I never did that and seems like it's not working usually, normally. If you want to, no, that's not what I want. box2D test. This is an application listener. So it seems like it's then really running an entire game context. So let's try that if that solves the problem. Which is fine for me. But the testing then can, of course, not be verified in the easy way that I thought we could test it. But yeah, let's see. So we have here something in, let's call that the test launcher. Here we have the main method, and we need all the imports from before. Also, we might need, no, we don't need that one here. We are missing some imports, unresolved reference. Why is that? Okay, I think that was just some problem. So startup helper, a dependency on module main. No. We skip that one. We don't need macOS stuff. We have it like this. Okay, so we will have a window, the LibGDX application. And here we pass in the test screen. I don't know. Let's call that jump test screen. Or jump test app. Something like this. Then we need a jump test app, which needs to implement an what is the base class of all of this stuff? So we have the game. The game is an application adapter. Okay, I think it was that one. KTX application adapter. This is what we need. And now almost everything that we did here, let's bring that to this test app over there. And this stuff here as well. So there will be the create method where we do something. Then we will have the render method where we do something. And we also need the dispose method. And there we, for example, dispose the physics world and also the entity world if anything needs to be disposed. In the create method, we will create the test entity, and in our render, we will update the world. And the assertion or the test where we are going, that one we need to check. So for now, it will look something like this. We don't render anything. So we might need to add the physics render debug system. And there we need 2 more things for this test here as well. Wow. What a day. Everything that I wanted to do is not working out the way I wanted to work out. So we need a viewport and an orthographic camera, which we used in the game screen, which is that one here. So like this, and also we inject those 2 things so that the physics debug render system is working. That should be the minimal setup. And I hope that we also need to override the resize methods. And from our game viewport, we call update with width, height, and we center everything. And now we should at least see something here. That one we move to position. Yeah, let's move it to position 1 and 1. And also we don't want to jump immediately. So the buffer, we don't set it here. Okay. Does that work now? So we have test launcher and let's run it. Does not work. Cannot invoke create shader because GL is null. I could imagine that the batch is missing. No. Does that one have a... I don't know. That has some internal rendering going on. Why is that not working? Why is everything today not working? Okay, let me take the reference stuff where I know it works. So we had Mystic Mutz, and I think there were some test classes in here. So first of all, build Gradle. I need to have all of that and use JUnit test platform. So let's see, did I forget anything? Backend, box 2D, platform, Kotlin tests, and the assets folder, which I did not add, but in case we need it, let's add it. And then we have a test package where I had a test class which looked like that, which again is jump test app, whatever. Then I apply something. I set the title, windowed mode, and yeah, okay, we don't need an icon. That's okay. Then what is the test application? That is I use KTX game here with a screen. Yeah, can be used, but I think the application adapter should also work. And then most likely I just implemented a screen. Yes, a test screen. I'm really confused. Why do I have a null pointer exception with the create shader stuff? Ah, yes. I get it. Okay, so all of that needs to be called after the create method. So most likely it is really easier to have just a KTX game and then have a KTX screen as well. And there we create now a separate one, which we call jump test screen. Okay, I think we are getting somewhere. So this stuff here must be part of the screen. Then this one here is also part of the screen, which is a KTX screen. When we show the screen, we will create this entity. Then in the create, we need to, we also need here something which is like a screen factory, which is a function that returns a KTX screen, and then here we have a add screen. While test screen equals screen factory, so we call it here, and here we add the screen, and also we set the screen like this. I think that should work. How did I do it in here? Was there a better way? Where's the app here? So add screen, and then, okay, I did it the same way. Good, then resize, that needs to be part of the screen. Render needs to be part of the screen. And dispose as well. So we don't need all of that. All of that can move inside our test screen, but we have show, we have resize, and we have a render method, which gets the delta time, which we maybe also should use here, since we are now far, far away from a normal unit test. Okay, so finally that hopefully should now work. What we need here is a screen factory, so something that creates the jump test screen. I think that should work. And now let's see, please. Missing screen instance of type jump test screen. Haha. Really? So we have a test screen, yes. We add this screen, but maybe not correctly. What is that doing? That's internally calling it with the type. So it should have the screens. But yeah, it did not add it with the correct type, I think. So test screen, I don't know. Then maybe whatever it is here, set screen, KTX screen. Maybe it's just added via with the interface. I'm not sure. Let's see. Okay, so finally we see something. Whoa. That took quite some time. So now we have that one. But now the testing is actually harder to make. But let's see. So we won't have any unit tests. So this one simply does not work. So we remove all of it for now. Then in here, we need now something more easy. So we have the test entity, which get lazily initialized. And this is our test entity. Okay. And finally, we also want something more. By the way, I forgot here the dispose method. So where we want to dispose the physics world and also the normal world. And in here, we also want to create another body. Which looks a little bit different. So the position of that one is maybe 2. And it should be a box again with a width of 1 and the height would be 3, for example, that we can see if we are jumping high enough. Maybe that would be a good test case. Since the box is wrapped around the center, let me think that through. So we have here maybe 2.5. Then it should be good. And the height should be 1.5. Yeah, I think something like this. Also, that one is static body. It's described like here. And here we want to have a body definition of a dynamic body. So that's the dynamic body. We don't have gravity. Yes. Yeah, let's see. How does our test setup look like now? That does not look correct. Why? What happened now? Why is also the box no longer showing up? Didn't we have a box before, but now it's gone? Where's the box? What happened to our box? We have a 16 by 9 view. We are never calling the test entity, so that's why it's not getting created. That makes more sense. So in here we call test entity ID. I don't know. Does not feel right. Just test entity. Will that also work? Test entity is not used. Yes, thank you for helping me. My brain is already shut down for today, and I really struggle here how to correctly implement the jumping functionality. So that looks now a lot better. What we need is create a wall to verify jump height, something like this. And currently our wall is too much to the right. So let's bring it back to 2.5. And since everything is centered, it's 1.5 and it goes 1.5 down, which is 3. It's 0. So we want to move it up 1 more. I think that should give us the... Okay, it's a little bit too much. Maybe it's just 2. I think 2 is correct, right? Yes. And maybe bring it even a little bit closer to the real entity. Okay, so that looks good. And we want that this box is now jumping actually exactly up here. With a single jump, that would be the goal. So what we want is here, if GDX input is key just pressed. Yeah, is key just pressed and key space. Then from our test entity, we want to access the jump component. And we need the context of the world. So here we are somewhere. I think that should be the thing that we want. And jump buffer is equal to jump buffer time, and import that. So that's the thing that we want to do. So now let's rerun this test screen. So we press space. It's flying upwards. Okay. So first of all, we are updating the physics system once a second, right? Which is good. Which is actually very good. The problem is that our entity will never stop falling because we don't have a gravity. Yes, which also makes sense. So let's bring back the gravity of -30. That's the one that we used in our game. And maybe update it, I don't know, 4 times a second. I think that way we should still a little bit see and understand how it behaves. Ah, shit. And now we are falling through the floor. So we need one more. Create ground. So we need another physics body, which is our ground. And that one has a position of 0. Then it's like this, I think. Then it should be quite long that we don't fall down. And a height of 1. Is that correct? It's not 100% correct. Why? Because we are here. Because here we also we have a position of 1, but the box goes below. So it's actually 2.5, which means here it should be just 0, 0, right? That should be now correct. Yeah, okay, so that looks good. We are no longer falling through the floor. And let's jump. Why is it only jumping like almost 1 tile, but it should be more than that? Where's it should jump 2. We have here a wall with a height of 3. Okay. So first of all, we want to jump a height of 3. And let's update here some more. Yeah, we can also jump multiple times, which is also not good, but we can test it. So it's funny. So the height seems to be constant, which is good, but it's the same problem as in the game before. It's not free. It's definitely not free. Which is not good. But we used a special formula. I don't know why the formula is not correct, because we saw that actually multiple times in the internet. So it should be correct, or maybe I'm applying it not correctly. Not free? What do you mean with not free? So a couple of adjustments that I want to make here. First of all, I want to apply here the entity tag and make it a player. And we don't make it a property in here because it looks weird that we call here test entity. This is already quite strange. Second thing is, I don't want to react on the input here. I want to let this entity automatically jump. So in our world, we have a family and we want to get all player entities. And for all of them, what we want to do, we want to check entity. No, we want to get the physics component. And if the body position is equal to the start position, which is, where is it? 1. So when we are on the ground, then entity jump buffer equals jump buffer. So jump automatically. That should be it. And also let's update a little bit more. Let's make it maybe 60 frames per second for the test case to see it in a better way. Okay, it jumped once and then it never jumps again. What? Why? And also it looks like it's now jumping correctly with this update rate, which is even more strange. Okay, so physics body, okay, velocity. So here I would be interested now. What is the position of this body? Exception during file facade, code generation, something. Okay, so it seems like maybe because this is this JNDI stuff, it cannot be easily debugged. So let's print the value here. Is it never going back to 1? Is it maybe 1 dot something or 0 dot something? I could imagine some inaccuracy. Yeah, it's 1 dot something. So to fix that, we use the libgdx math utils is equal, and then we check the y position. Is it equal to 1? And the tolerance is 0.1. Okay, so now it should jump automatically all the time. And it looks like it's jumping higher now than it did before with an update rate, with a lower update rate. That's interesting. That's really interesting. But how can we properly debug that? So what I want to achieve, and I don't know how to achieve it at the moment, I want to verify that the maximum position here at the top of the jump should be a value of whatever we say for the jump height here. So currently it should be 3. So I want that the entity here always at the top has a value of 3. So ideally, I think it's the easiest would be that we have it in the title, the height of the entity, but since it gets updated so frequently, it would be hard to get the correct value out of it. We would somehow need to identify when is the turning point, which would be that the y velocity is very close to 0, and then update the title. Let's Yeah, let's try it like that. So first of all, we just need the body from no, just the body from our physics component. So we can use the destructuring here. And I think it was the first one. Yes, it was the first one. Okay. And one more thing. So what we want to have now. So if mathutils is equal body linear velocity y is very close to 0, maybe also with a tolerance of 1/10 or maybe even closer is good enough. What we want to do here is then from our, I think it's graphics, set title. We want to set the height, which is body position y. I would say so. So let's try that. It says that the height is 1. Because the velocity is also... we need to have one more check. The velocity also becomes 0 when the entity is jumping. So we also need something like body position y is greater equal 2. So there we know that we are away from the ground. And then we are never updating the title. Maybe the tolerance is then too small. Let's make it then again like this. Okay, now we have it. So it says now that the position is 3.9. Which is correct because we moved everything up by 1. I don't know why I did that, but I did it, which is a little bit bad. So let's move back to position 0, position 1, and that would be -1. Okay, let's see. And now that one is not jumping anymore because that should be a check of 0. And here, I think that's still good enough. Okay. Okay, so 2.9 something. Does not look like it ever reaches 3, but it's 2.9 something. Okay. Okay. Then the next thing would be, what if I change that to 5? Are we now jumping very close to a height of 5? We are never updating the title anymore. Why? Position The tolerance again a problem? Yes. Okay. So 4, 9 something, depending on when we enter here with the tolerance. So looks like it's very close to the correct value. I think that is good. What I'm wondering now, so before we have a different update rate. The update rate of the physics system seems to change how high we can jump, which I find quite interesting. Static import 4 is equal, please. Yes, soon. What I find interesting, why is the jump height different depending on what kind of update rate we use for the physics system? Now I don't see the value at all anymore because most likely we never reach the correct tolerance values here. So we want to be greater 2, and here Yeah, let's increase the tolerance once more. Heh, why is it never printed now? Okay. 4.7 something. So the lower we set the update rate for our physics system, the lower we jump. That is really weird. Why is it like that? I don't get it. Now it's just 4.1. Huh. I really don't get that. So when we have an update rate of 60 frames per second, we are close to the value 5. So I would imagine that we are actually jumping a height of 5. When we lower the update rate, then we are just at 4.8, but we are never at 5 or 4.9. So we jump lower when the physics update rate is lower. Why? The reason could either be that because we are setting the linear velocity directly, that we get some inaccurate simulation behavior, and we should maybe use a force or an impulse. Or what else could be the problem? So let's imagine I set in the jump system, let's think it through. In the jump system, we set the linear velocity. It has a fixed value. And that value has no impact at all until we reach the physics system. And that one is then calling the step function of the world, which could be either 1 step or 2 steps, depending on how often we enter it. But in the end, it should not matter, right? Or why does it matter? Because it just does the simulation with the fixed value that we set before, and it either simulates 1 step or 2 steps. But why is it then that far away from the expected result if we have a lower update rate? I find that really strange. Could it be that the lower update rate just skips over the state with the highest jump height so that we only observe the body while it's already falling? Yeah, I'm thinking also towards a direction like that. That maybe it actually reaches that position, but because of the lower update rate, we don't see that. So it looks like we are not jumping that high, but everything that we did, so the formula that we set in the jump system, everything is great, but it's not accurate enough because the update rate of the physics system is not high enough. But what does that actually mean? So I would then wonder, and that one I cannot easily verify with the current state of our game. I would then wonder if we have a ground like this. Okay. Then I also have a platform somewhere where I want to jump. And then I have my player. And I have the formula that he can jump. Let's say is a height of 3, and he can jump a height of 3 with our formula. If we just have the update rate low enough and we just see it like this, does he in reality still get simulated above to the platform if we would have a jump trajectory like this one? Would he end up here, or does he end up here and fall down because he's colliding here? That would be my question, but not. I don't know how we can easily verify that. Could you add a line body at the top, like da da da, and see if it collides? Haha. If it fires a contact, that's. I like the way you are thinking, Coppity Fish. Let's do that. So we are in here. So first of all, everything is a little bit off screen. So I want to bring it back that we can see it here. So now everything is here. And also let's move everything, I don't know, 3 units or 4 units to the right. So that would be 5. That would be 6. And that would be 4. Okay. And the ground is maybe a little bit too long. Let's make it 6. Okay. That looks now good. And we want to have the automatic jumping again. So what did we have when the body position is equal to 1? Correct? Now he's jumping, right? Yes. And also let's go back to the correct jump height that we want to test, which would be 3. And let's keep the update rate to whatever we had in our game. Okay, so your idea, which I like a lot, is that we add a sensor. So jump height verification sensor, which is simply another body, which is a sensor. I think we need to set that on a fixture, right? So the position of that one is... yeah, maybe something like the ground. So it's 4. The height is 3, for example. And is there a line shape? No, but we can have a chain shape. Let's make it a box shape. I think that's the simplest one. With width of 6, a height of 1. And with that, I need to move it up by half. I think so, yes. And we need to make that one a sensor true. And that should do the trick. No. 4. Yes. Okay, but I need to move it up by 1 more, actually. So that way, so the gap between here is exactly 1 tile. Not a tile, but the size of this testing player. And we want to see if there's ever a contact with that one here at the top. Correct? Yes. So let's make this screen a contact listener. Implement a billion of methods, which we all don't care about. I think everything here can never be null, so we can also remove the question marks. And let's also move that above the dispose method. And now one more thing. Set context, set continuous physics. What is that even? Enable, disable continuous physics for testing. What does that mean? For testing. So it seems like that would be maybe something useful. But anyway, we want to set the contact listener, and that one I want to pass this. This at game screen or jump test screen. Exactly. Good. So we have then a begin contact. And the contact has a fixture A and a fixture B. So the fixtures are colliding. And to make it easier to detect them, the character test entity. So that one will have a user data of player, and our sensor below, that one will have a user data of height sensor, for example. We would not need the user data here. We can ask that property here, but just to have it clean, let's do it like this. So fixture A and fixture B. And now if fixture A user data equals player, did we call it player? I already forgot the name. So player and height sensor. So if fixture A is the player and fixture B is our height sensor, or the exact same thingy, but the other way around. So fixture B is the player and fixture A is the height sensor. Then print line collision. Okay. Let's see. So either that one is not working or we are never colliding. Let's increase the update rate. Also never colliding. You probably want jump height minus tolerance instead of 5. So first of all, this one we no longer need. What do you mean with 5? Ah, you mean here. Yes. So it would be okay, let's make it here. So the jump height is 3, which we set on the component. And the Y offset is 1. That's why we have here 1. We have here 1. We have here... No, let's not do it like this. Let's get rid of this Y offset. So we have here a jump height of 3. So it would be 2 plus the jump height. And 2 is depending on the height that we choose here. So something like sensor height is equals to 1. So everything starts at 1 plus jump height plus sensor height. And that one is the sensor height. And here we want to have some tolerance. Let's try 1.1. This is then not correct. Let me think. Because if that one gets bigger, the position needs to be smaller. So it would be 0.9. What the hell? That's too confusing for me. Because it's always centering this box around the stuff, which makes it quite confusing. But we can actually fix that like we did it in the game. So let's have it like this. And we pass in here the position of the... And I think half of it, right? And this one, half of it. Now the box, so that one should be now the bottom left corner of the sensor. That's something completely strange. But too late for me to think about those stuff. So we will work with fixed values. So we have a jump height of 3 and somewhere we integrate this jump height. I think here. Okay. Is that good? Yes, that's good. And now that one has a height of 1.1. So it's a little bit of a tolerance. Now there was a collision. Not all the time. It's every other time. Yes, it's really every other time there is a collision. Also quite interesting. Now let's increase the refresh rate to 60. Now we are actually never colliding. Which is also interesting. What is if we go down to 30? Also never colliding. But with 45, it's constantly every other jump. Yes. Okay, so what we do know, that this update rate here for the physics system has an impact on how accurate it can detect the collision, which also means the jump height. If your jump height is 9, the line should be at 9 minus 0.1 or something. Otherwise, you wouldn't get collision, no? Yes, you are correct. That is what we want to achieve. But the problem is that Box2D always... I don't have a line shape. I would need a chain shape, most likely. Which I think is not that difficult. Let's create a chain shape, because the box is always... centered around this position, which makes it difficult to work with. Let's make a chain shape with just 2 vertices. So we can pass in here an array of vector 2, which is good. So we have an array of vector 2, which has a size of 4. No, we did the other function. Array of And then we pass in here the vector 2. So the first one would be four, and then 1 plus jump height. So 4 and 1 plus jump height minus 0.1. And the next one would be, for example, 6. And that's it. And then we pass here the vertices into the chain. Which it doesn't like. But what does it use? A variable argument vertices or a float array? Why is it not taking an array of vector 2? But I think if we pass it in with the star, that's already good enough. Okay, and finally, of course, we still want to set it as a sensor. So now we should hopefully just get a line. And the position here should be 0, 0. Let's see. I think that should give us the... Yes, this line. But it's 1 plus jump height minus 0.1. That's also weird. Wait, when I don't have the tolerance here... Why is it not exactly here? The chain. Shouldn't it be exactly at the top of that little rectangle here? The player has a height of 1, and the wall has a height of 3. But it has position 2, so it's... Ah, okay, so it has actually 3.5. A height of 3.5. Maybe the entire setup is not 100% correctly. So actually what we want... So this is correct. And we can clearly see that it's actually jumping through that line. Because it, of course, has a size of, let me think, we need to add a height of a half to it, I think. Let me check. Now it should, yes, now it should barely touch that. So let's make here the tolerance value again, which is maybe 0.1. So if it has, we move it a little bit down. Okay, so do we do something when we collide? Yes, we print the collision, right? Okay. Okay. So now again, for whatever reason, every other jump is colliding with the chain shape. But not every jump. Also the wall, we actually don't need that at all anymore. Okay. Let's say jump height of 5. It's the same. No, now there's no collision at all. So it looks like it's reaching it, but it never reaches it. And now let's increase the update rate to 60 frames. So now the simulation should be more accurate. Yeah, so with update rate of 60, it's again every other jump. What if we have now the jump height of 3? And then it's now every jump. Okay, so it seems like, first of all, thank you, Fish, for the hint at that late hour for me. So that helped now a lot to understand it better. So first of all, it seems like this update rate is more like the accuracy of the simulation. So that the values and the formula that we are using, they are totally fine, but the simulation of box 2D in the background is not 100% accurate. So the higher, the more often we update the simulation, the better or the more accurate is the result. The question would be, how accurate do we need to have it to get then a good play result? That one we can only verify once we have a real map and can jump around a little bit. But I would say that we most likely go then with a higher update rate. What is the recommended update rates in LibGDX box 2D? There should hopefully be a wiki page. And there should be something with the value 45. No. Dot step. Okay, here. The first argument is the time step, or the amount of time you want your world to simulate. In most cases, you want this to be a fixed time step. LibGDX recommends using a value between 160 of a second and 240. Wow. We will roll with 60. My guess is yours. Start jumping also based on tolerance. So sometimes you start the jump at 0 and tolerance, and sometimes exactly at 0. That's actually also a factor. You are correct. You mean here, right? We can make that here maybe more accurate. Let's see. No. Seems like we cannot do that. Okay, now it's a lot better. Okay, that is the with an update rate of 60 and a height of 3, we are triggering the collision all the time. Let's see with a height of 5. There we never reach it. Okay. What if we would go up here to 240? Wow, that is actually, okay, wow, I'm impressed now. That is actually what I would really expect, because we place the chain shape 10th with our tolerance, 10th of a meter below it, and it looks like the box is now really always moving through this line here with the tolerance factor. So even if we would use here a tolerance of 0, I guess it would still... Okay, not all the time, but sometimes. So it's very, very accurate when we use this update rate here. Impressive. Okay, but I think we don't need that high amount of accuracy. And 60 is good enough for our purposes. And the only thing that we need to be aware of, that it's not 100% correct. It's quite accurate, but not 100%. But I think it should be good enough for our game. So what we learned is, first of all, our physics system update rate. Let's increase it to 60 instead of 45 times per frame or per second actually. And in our test scenario, we could actually go to 240. And the jump height that in the game, we most likely will have a jump height of 3. Let's say the tolerance is very, very small, something like this. And let's try it out once more. Oh, I need to have the debug line. Yeah. So here, it looks now very accurate that it's always detecting that. So that's cool stuff. Thanks a lot for helping me. I really struggled with that a lot today. Okay, so what I want to do. So we actually did not really write a real test, but we have at least some setup. But what I want to do, so I wanted to write something for the move system. We did now something for the jump system. Whatever, we can add some other tests later on. The coyote time we did not implement, and I'm not motivated to do that today anymore. So we moved it to the next day to have that one available as well. And what I want to do as a last thing for today is to run or create a GitHub action that at least triggers a certain Gradle command. So something very simple like task, build, and then it should make a clean, which might not be necessary, and then run a build. The build is also executing the tests. It's also compiling and it's bundling the jar and everything. What is it doing? Oh, it also triggers TVM. No, don't do that. Then we need to do something different. Then we just want to have the verification. What is verification doing? It's compiling, running the tests. Also again with some TVM stuff. Because I'm on the project level. Wait. I was wrong from the beginning. So if we are in the core project, there we want to have a clean and a build. I think that should be it. Yes. And that one we want to run over GitHub now. So what do you think about K2? I'm actually waiting for that because K2 compiler promises amazing things, and I want to update then the Flex component system to that. But currently it's again just some beta stuff. I think they introduce it officially with Kotlin 2.0 if I'm not mistaken. And then let's see. And yes, the groovy Gradle files, I also don't like them, but the GDX lift-off setup creates always the groovy files instead of Kotlin. Although I think Kotlin is nowadays the official language for Gradle. I prefer Groovy for Gradle files, even though I prefer Kotlin for coding. Really, I personally, I think it's a very bad decision that they support 2 different languages for Gradle, which is for newcomers also a little bit more tricky. Sometimes you see Kotlin style, sometimes you see Groovy style, and also the syntax is quite different from time to time. Like things like that, I think, or special syntax stuff is with Kotlin completely different. You want Gradle check. Do I really want Gradle check? Where is Gradle check? Is it this one? Compiling. Testing. Don't know what check is doing. Okay, then let's execute the check task. If you run build, it makes you run build on all sub-projects. Yeah, exactly. So I noticed that I'm here on the top level. I just want to be on the core level, I know, or core project or source set or whatever that is called. Also, running clean before build is the dumbest thing you can do, especially if you do it in the CI. Why? Because the CI is never running with already existing files, especially on GitHub, because it always runs or starts a new virtual machine. So clean does not make sense, or what is the reason? Because from experience, most for sure not in that project, but in more complex projects where you are maybe copying files from different folders. So you have a test, quality and production environment. And for the test environment, you want to pick that sort of property files in the final jar. For quality, you want to have those files and things like that. And there, in real examples, I had more and enough times the verification that the build tools, Gradle and Maven, are not always creating the correct build if you don't clean before. Sometimes they have things cached and think that they are up to date, and then they put something into your jar which is not what was the latest version, and then you have some problems. So it even uses then the test files instead of the productive property files and things like that. So that's, for me at least, I always call clean before when I do things like that, to be on the safe side. But anyway, I want to get that now going, and long time that I introduced some GitHub workflow stuff. So first of all, let me quickly go through all the changes that we had today, which took really way, way longer than I wanted it to be with this jump thingy, but it was not so easy to implement, and it's still not what I actually want in the end, because we don't have yet the ground sensor check, so if we can really jump and things like that. So it's really just some, I would say, quick and dirt implementation, and not the final result that I want to have. Okay, everything green. Yes, that's good. Then the keyboard input processor with space. That's also fine. Here we updated the interval to be more accurate. We fixed something, some comments. Okay. Here we added the jump component to the player. That file we don't care about. Then we have the test launcher and another file that we don't care about. And the unversion files are the graphics. Okay, so in here at basic jump functionality, but we call that still a work in progress. Been enjoying the series. Very clean code, very satisfying to watch. Yeah, thank you. I think today was not really satisfying because we did not achieve the perfect result that I wanted to achieve, but still you saw something. And also I think what is interesting, because when you watch YouTube tutorial series, which I did as well, and you always see people, they are writing down the perfect code, everything is running the first time, everything is simply perfect. And I can tell you something, that's simply an illusion. All of us which are doing those tutorials where we show something, you code something before, at least you should do that if you want to have a good tutorial series. You code it beforehand, you go through all the struggle, and in the end you have the working example, and you just code that. Usually I did it from a second screen where I just write down the code, and I can always cross-check if I did everything correctly. But in real life, before the tutorial series starts, you have something that you saw today. So me sitting down, trying to figure out why I don't get the result that I expect, and try to find out the problem in the end. in the final tutorial series, you would just see, hey, let's implement a jump system and we need exactly that formula and we need that specific update rate. But yeah, coming to that thing, that is something that you don't see in videos. So don't get demotivated if you struggle yourself in some of the projects. That's just normal. Everyone is struggling. Even people with experience. Fell asleep last night watching you do some kind of command architecture with input. Yeah, the keyboard input processor. So first of all, you should not judge Gradle 8.6 by something that happened in Gradle 4 that was released like 5 years ago. Yeah, that's true, but I had the problems with Gradle 6. something. So it was not 4. For sure, they improve those things all the time and also the cachings. But just to be on the safe side, because I know for sure I had problems with that, I just call clean. It takes like, I don't know, a second to delete this folder. And of course, it needs to compile everything then from scratch. But at least I can be sure that it's doing everything correctly. Also, you're right that theoretically clean would do nothing in the CI as it starts fresh. But what you should do is use the Gradle action, setup Gradle GitHub action, which sets up the Gradle cache. And what you are describing just sounds like a bad configured build. Could also be the case. Anyway, we are now trying to create a GitHub workflow for the tiny little project. So what I know, GitHub helps me with that when I click on actions. And then can I write here Kotlin? Or maybe I don't need Kotlin. I just need Gradle. And I want Java with Gradle most likely. And then I just adapt it to something. Build and test a Java project using a Gradle wrapper script. Yeah. So, the actions are always located in a .github workflow folder. In the past, I think it was an action folder or something like that, but nowadays it at least is GitHub workflow. And then you have, I zoom in a little bit, you have a YAML file. I love the ending of this file extensions, YAML. And we remove, of course, comments. Then action usually can have a name. So this one we will say, I don't know, check or verify project via Gradle. Then when do we want to fire that? We want to fire that when a push is happening to the master branch and yeah, also a pull request. We will not have pull requests because we are directly committing, but maybe someone out there wants to add some features to this little game then. And then when he's creating a pull request, we also want to trigger that action. Then you have jobs, and there you can then have, I think, different jobs. So this job is called build. Is that the name? I'm not sure. Then there's some dependency submission and other stuff. And I think we don't need most of it because what we need a system where it runs on. So for example, Ubuntu latest, permissions, seems like it only should read. And then we have multiple steps, which is first of all, checkout, setup of JDK 17. We would not need that because we just have Java version 11. But we do need the JDK even for Kotlin. Then we configure Gradle for optimal use, including caching of downloaded dependencies, blah, blah, blah. Okay. Whatever. So the next one would be set up Gradle, where it throws in that specific action. We just trust it. Then build with Gradle. And there we need to write something else. I think in our case, it's core. Check. Do you write it down like this? Not 100% sure. We will test that. And what else does it now have? Dependency submission. Generate and submit dependency graph. No, we don't want that. I think, I'm not an expert with that, but I think that might be already it. Where do I actually specify the Gradle version that it's using? Could I maybe set that up here? Do you also reinstall IntelliJ every day because maybe the settings got corrupted? Yes, I do that. It should use the wrapper, right? I have a reference, of course. So let me check here what I did. Here we can. That's also actually something good that we, or decent that we want to add. Where was it added? It's under branches. Okay. So here we want to also ignore certain files that, for example, if we update the README file, we don't need to check the project if it's still working. That does not make sense at all. Also license and git ignore, and the same for the pull request. So if those files get changed, we don't need to run our workflow. So this is this paths ignore stuff, which is quite nice. Also workflow dispatch is good to add. From what I remember, that one allows you to manually trigger the workflow in the GitHub Actions tab. That for whatever reason, if the workflow is not properly running because we set up something wrong here below, then we can manually dispatch it and try it once more. Just prefix your commits that should skip CI with something. I don't see the text again because of this emoji pop-up. Concurrency, we don't use that. I don't know, but that's too complex, I would say, for this little task here. Also, this is what I used for the Flex library. So they are actually built on different operating systems because of the native platform target. And for example, on Windows, you cannot build for macOS or Ubuntu, for example. And since I need for the Flex component library, I need all the targets. So I have a matrix here of systems. Then, so here we have Actions Checkout version 3. Here we have Actions Checkout version 4. So there's something new. I could update here as well. So then we have set up Java. Then we have validate Gradle wrapper. Here have a wrapper validation action. Then some Kotlin Conan cache. We don't need that. And Gradle build action. I don't know. And some publish stuff. I am missing somehow the connection that I use the... okay. So this one uses the Gradle wrapper from the project, I could imagine. Does it do that? But let's see. So there should be a GitHub wrapper validation action. And there is also a version 2 now. So simply add this action to your workflow after having checked out your source tree and before running any Gradle build. So we will use the newest version here, which is down there. So we don't use this specific action here. Set up Gradle wrapper. And finally, we want to Gradle build action. What is that one doing? Or let me Google it in more general stuff. GitHub run Gradle or run Gradle task via Gradle wrapper in GitHub Actions. executing Gradle builds on GitHub Actions. That one sounds cool. So we have already set up a Gradle project, blah, 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 enable build scan, whatever. Configure GitHub Actions. That's the important part. So runs on Ubuntu. We have check out project sources. Okay. Then set up Gradle. I think we just, let me close that one. We just verify the wrapper and then we just use it most likely like here. And I think that's it. Is the first one, can I also write it like this? Check out project and remove here the minus. Does that one work? So like this, first step is check out the project. Second step is set up JDK. Third step is validate the Gradle wrapper. And fourth thing would be to run the check command on the core project. I think in theory that sounds correct. If it's working, we will see in a moment. How can I save it? Commit changes. Yes. Create Gradle YAML file. No. We will rename that to verify. Okay. We did something. Now in our actions, that one does not trigger automatically. Okay, it does trigger automatically. I thought we need a push or something or a commit, but seems like it does it automatically and it already failed. Because process completed with exit code 126. Ah, of course. So permission denied, most likely that means we either need to make that executable, because I think by default there is some permission set on that specific file and we need to fix it. Or another idea that I have, didn't we say somewhere that we are doing something read only? So this permission here contents read. Do we maybe need to update that to something else? I mean, let's be honest, most likely this is a error that almost everyone had already, so we can simply paste it. And Google will most likely tell us what to do. The error may also be caused due to inadequate permissions to run shell. I got blah, blah, blah. On fixing the permission on shell script, the issue got fixed. There's some... Oh God. Windows make or add file execute permission. Command line. Change mod. Not sure what that is. Was it -X or something? I've been telling my friend how awesome LibGDX is, but he casts doubt on it, saying maintenance has slowed down on it recently. Anyone concerned with the future of LibGDX not being maintained? No. I think what some people are misinterpreting, and in my opinion, unfortunately, that's a common way of thinking, which I think is not good. LibGDX is a library which got developed since the last, I don't know, 10 or 15 years. And when you go to the GitHub page, you will still see that there are pull requests, merge requests, there are issues raised, there are discussions going on, there is a Discord channel. But of course, they don't release a version like every month or every other month. So maybe a couple of years ago, there were a lot more releases because, of course, there were way more bugs in the library than they are today. Because now it's simply a very mature library, which has, I would say, most likely all the features that you need to develop 2D games at least, maybe also 3D, but I never tried that out. And there are no big bugs or issues in the library itself. So that's why, of course, the amount of releases slowed down. But it's simply an indicator that this library has matured enough and it's safe to use. It does not mean that it will not be maintained or that it's maybe it does not work anymore in 1 or 2 years. It simply means that it's mature enough and they won't throw out updates all the time to also not break older games and things like that. So I think for me, I would say it's still safe to use. Change mod plus X Gradle W. So let's try that. I think the next problem here is that Git does not detect that as a change. If you change the permission on the file. Change wurde nicht as a command. I don't have chmod. Why? That's interesting. I don't have chmod. Huh? That only works on Linux. Love it how you just ignore me. I read too slow. Okay, so how does it then work on Windows? Windows mod plus X. The key phrase in your question is blah, 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 and the answer depends on how it's being received. Unicode, I don't want that. Git update index minus blah, blah, blah. Does that work? We will just copy and paste different things and see if they will ever work. It did something. Make Gradle W executable or add execute permission. So maybe that's already solving our problem. Let's see. Merge. Okay, yeah, because we created the workflow on GitHub directly, so we need to get that into our local branch. If you would have requad my previous message, what? You would know how it works. I told you to run that command like 5 minutes ago. You would have just reread that message. You would have fixed the problem. Which message? I don't see it. I just see the one, just prefix your commits that should skip CI with CI skip. Okay, now I can read the message. That one that I didn't see before. Did not know about that. So when I write, is it with space? That one I cannot see in my chat window here. Is it like this? Or do you write it together? Like this? So coming back here, we should have a workflow which runs now. Welcome to Gradle 8.6. So it uses the correct Gradle version, which is good. And also it seems to be able to execute now something, which is also good. So I think we fixed that other problem. without a space. It doesn't matter. GitHub just looks for the word skip. I don't know. I really don't see the message. Don't know why. At least not a message regarding the change permission of the Gradle W file. But our build was successful. Hey, hey, hey. You send it to me on Discord. I don't have Discord running at the moment. But yeah, that one worked. Let's do one more thing because that's also interesting for me. What did it do now? So let's have another window. Let's go again on GitHub. Let's go to our Quilly project. Workflow, verify YAML, and now I want to see something. So it says setup job. I think that's the name that most likely we cannot change. I guess this is some GitHub internal action stuff. Then we have checkout project, which is this one. Then we have set up JDK 11, which is that one. Then we have set up Gradle wrapper. That one we have here. Then we have build with Gradle wrapper. That is that one here. The name is not 100% correct, but let's keep it. And then some post setup, post checkout, and complete job, which is just part of the pipeline. But cool stuff. So we have now some automatic workflow on GitHub, which is always executing the check command of our core project. Did it really do that, by the way? Yes, so core, we can see that here. So it compiled the code, it executed the tests, and it did check. I don't know what check is. The important part is it's compiling the project if everything is working, and it's also executing the tests. Unfortunately, the test that we have written today is not a unit test, so it's something that runs in a separate window. And the reason for that is that we needed box2D. Box2D seems it needs to it requires some context and not just a standalone Kotlin file. So it needs a little bit more information with this box2D platform. And also seems like it required the rest as well. So some libgdx context here as well. And since we use the box2D debug renderer, we just have like a separate test game application which runs the test. So there is no verification yet, but at least in the future, if we will add some tests, they will be checked here automatically, which is cool. And also the last thing that we do today here in the stream. So we have completed another day where we did not do everything that we wanted to do. That seems like going through the entire stream project here, but that's fine. So tomorrow is a day with some more easier stuff at the beginning. Let me order that quickly. So tomorrow we will implement, first of all, animations that we have a run, jump, and fall animation. Then we will implement a camera system that we can move around in our maps. Then we will, let's call that in general, optimize jumping. So we will need a food sensor and check if entity can jump. That is what we missed today. Then we will add this coyote time. Okay, that one was mentioned here. So that one we will do here. And finally, we will make some optimizations to the physics body as well. And there I wanted to check one more thing. So in the collision editor, when we select here shape, yes, this shape has properties, which is great because I already have here some idea. that we can then use. And the idea is that the player will not look like that. The player will be something like, where can I draw? Will be something like this. So on the left side, we will have a line. Oh, wait, one more time. Like this. And this will be when we go to the left to a wall, and that specific fixture here will have, is it friction or restitution? I don't know the correct English terms for that. But anyway, one of these values will be adjusted that we don't stick to the wall, because normally a box 2D fixture, when you jump against the wall and you still move in the direction of the wall, then you stick to it like a slime. And we don't want that, so we just want to fall off the wall. And we will add here then some properties like, I don't know, is it most likely the friction, I could imagine, which has an integer value or a float value, I guess. And we can then modify that here in the collision editor as well, which is really great. I like that. Then we will also have the same thing on the right side. So if we are in contact with a wall on the right side, and finally we'll have something below that's maybe a box, and the box will have a very high friction, so that on the grounds, if we are also in maybe on a slope, that we stick to it so that we don't move automatically by that. And yeah, that would be the thing that I want to have for the player. Also, one last thing, let me remove the box one more time. Also for the head, when we are jumping, let me quickly open up Paint once more. So imagine we have a world like this. So we have a ground, and we have a platform somewhere, and then we have our player. So if our player is now here and he jumps, obviously he's hitting his head and he shouldn't move somewhere else. So that is totally fine. But if we are on the edge, like something like this, and we jump up, I think a better behavior would be if the player jumps outside like this, so that he doesn't hit his head here, because the head might be here somewhere in the center. So visually he's not in contact here with the platform. So he should jump out like this in the physics simulation. And I think we can easily achieve that if our head is also just a polygon, which has a shape, something like that. So first of all, a line, then something like a little bit of a triangle, and then another line. So if he's hitting the platform here, then he gets pushed out to the right side. And if he's hitting the platform edge here, then he's pushed out to the left side. So something like that. That would be my idea to optimize the jumping and the collision behavior a little bit with the player. But all of that we are doing tomorrow. So let's discard the changes for now. And let's see how far we come tomorrow. Stream will most likely start a little bit earlier tomorrow. I could imagine shortly after lunchtime, so maybe 1 or 2 o'clock. And then the entire afternoon, because tomorrow really I want to finalize all of that. That would be cool, because then we have already quite some cool functionality in our game. That would be great. Okay, now let me read some more messages. And so open Discord and read it. It will help you, I promise. You seem cranky, mate. Try taking a pill. That's just how he is. He was like that when we met, I don't know, was it 5 years ago or something? But in reality, he's a nice guy, because he gave me a Minecraft copy back then, I think. We played a little bit together. And also, he helped me a lot with learning Kotlin in the annoying way that he is and that he does. But I learned a lot from him. So I can accept his cranky way. And I know to simply ignore him. I can live with that. But I'm thankful to him, because he really helped me a lot a few years ago. And I learned a lot of things from him. Okay, so thank you guys. hopefully see you tomorrow. Thank you again, especially at Cop the Fish, with helping debugging the box2D stuff and this update rate and the jump height and so on. Was really not easy for me, and I appreciate the help. And yeah, hopefully see you tomorrow, guys. Have a nice rest of the evening and see you tomorrow at the stream. Bye bye.